We're in lesson 93, and today we're going to talk about something called the discriminant. The discriminant in this instance is the part of the quadratic formula that tells us what type of answer we're going to have. In this case, the discriminant is the numbers or the values underneath your radical sign. So this bit that I've highlighted here tells you what type of answer you're going to have. Now, we learned in lesson 70 that there are three types of answers. You could get a single real number, right? You could get two real numbers, or you could get two different complex numbers. And the complex are going to be the ones that are, they retain the radical symbol, or they have an imaginary number, something like that. But what determines all of this is this value right here. This is your discriminant. So let's figure out how we can just look at this and let it tell us which one of these we're going to get. So what we can do when we have our formula or our equation set equal to 0, we know that if we have, let's say, x squared plus 4x plus 4 equals to 0, we know that there's a 1 right here. That would be our A term. Positive 4 will be our B term, and positive 4 will be our C term. Okay? So our solution for the numbers we're going to sub in is A is equal to 1, B is equal to 4, and C is equal to 4. And that's what we would use within this quadratic equation. So let's go ahead and do that right quick. We are going to say x is equal to -4 plus or minus the square root of, we have 16, because 4 times 4 is 16, minus 4 times 1 is 4, times 4 is 16. So 16 minus 16 over 2 times a, which would be 2. So we have x is equal to -4 plus or minus 0 divided by 2. So x is equal to -2 plus or minus 0. You add 0, you subtract 0, the answer is still -2, right? So when b squared minus 4ac equals 0, then we are going to have a single real number. So whenever we have b squared minus 4ac equal to 0, the answer is going to be 1. A single real number. One real number. So let's try it with another scenario. If we have x squared plus 5x minus 1 equals 0. We have our 1 here, so a is equal to 1, b is equal to 5, c is equal to -1. So we would drop that into our quadratic formula. X is equal to, we would have -5 plus or minus 25, because 5 times 5 is 25, minus, and then we would have 4 times a, which would be 4, times -1, which would be positive 4. So that'd be plus 4, all divided by 2, right? So that would be x is equal to -5 plus or minus the square root of 29 divided by 2. So we would end up with, we would split that and we say x is equal to negative 5 over 2 plus or minus the square root of 29 over 2. So when b squared minus 4a is a positive number, which is a positive number, there are two real number solutions. Okay, we have whatever this value is plus this, whatever this value is minus this. Okay, so that would be two real solutions. So when b squared minus 4a squared equals 0, equals positive, a positive number, then it goes with rule 2, two real numbers. So we just have one more rule to check out. So if we have x squared plus 5x plus 7 equals 0, we know this is a 1. So a is equal to 1, b is equal to 5, c is equal to 7, right? So we'll drop that into our quadratic formula, and we get that negative 5 plus or minus the square root of 25 minus, and we have 4 times a, which is 4, times c, which can be 28, right? All over 2 times a, which is 2. X is equal to negative 5 plus or minus, that's going to be a negative 3 over 2. Right? We can't have a negative in here. So our answer ends up being x is equal to negative 5 over 2 plus or minus the square root of 3 over 2i. So when b squared minus 4ac is equal to a negative number, the answer is 3. A complex, two different complex numbers. So just by looking at this little bit here, we can tell what the answer is going to be, whether it's going to be a single real number, two real numbers, or two different complex numbers. And the complex numbers will have that little I right here on the end of it. All right. So let's look at some examples and see if we can just evaluate based on what b minus 4ac is. I'm going to clear this page. Our first problem is 93.1. And we have x squared is equal to negative 4x plus 2. So we have to bring this back over here and set it equal to 0. So x squared plus 4x minus 2 is equal to 0. We had to rearrange it. So now we have that a is equal to 1, b is equal to 4, and c is equal to negative 2. So let's do b squared minus 4ac. That's going to be 16 minus 4 times 1 is 4 times negative 2. That's going to be positive 8. Negative 4 times negative 2 is a positive 8. So we're going to have a positive number, which is going to be 24. So we're going to have the result of two real number solutions. Two real solutions. Right, that means no imaginary numbers. 93.2. We are going to look at this problem. Negative 2x equals negative 3x squared minus 8. I'm going to rearrange that and say 3x squared minus 2x plus 8 is equal to 0. Now we're going to do a is equal to 3, b is equal to negative 2, c is equal to 8. So b squared minus 4ac, we have 4, and then 4 times 3 is 12, 12 times 8 is 96. That's going to be negative 96. That's going to equal negative 92. So that means we're going to have two complex solutions. All right. Without even actually doing the problem, we can tell that already. All right, and that is all we have. That's all that we have. The only other scenario that we have is if b squared minus 4ac is equal to 0, then we would just have one solution. And they didn't give us one of those as an example problem. We just have to remember that. That's not common for b to equal 0, but it is possible. And that's all we have for lesson 93. I'll see you in lesson 94.